Okay, so this video is going to be a little bit tedious, but I think it's going to be a good video, and I think you're going to learn a lot by the end of it. But I'm just going to kind of go through it slowly because I really want you to have some processing time, and I'm going to go through it manually because I don't want to just sort of plug it into a computer and just spit out a result and leave you not understanding what's going on. So I've got this squiggle that I've just made. And it's not any function that I know of. I suppose I could find a function for it, but I just sort of drew a squiggle that kind of does what I want it to do. And because I'm going to be marking this up extensively, I've made a few photocopies of it. And so the point that I'm going to make to start off with is we have this concept of the integral is equal to the integral of f of x dx. And we've said a couple things about that. We've said that this gives you that the integral of f of x dx gives you the area under the curve. So in other words, if I want to find out what this area is, I integrate from like 0 to 2.5-ish, and I will get this area. And then this area is negative, and then this area is positive again. So one concept is that the integral gives you the area under the curve. Then the other thing is, the other concept is we say that f of x is the derivative of f of x, where f of x is the area under the curve, right? And so f of x is the antiderivative of f of x. So this is the other concept, and I shouldn't put it so. F of x is the derivative of f of x, and so it makes sense. F of x is the derivative of f of x, and so f of x is the antiderivative of little f of x. So f of x gives the slope of capital F of x. Okay, so if f of x, how are we going to use this to construct capital F? How do we use f of x to construct capital F of x? I did that in another video, and let me just sort of find out where I did that. I believe in chapter 2. So there's my chapter 3. I should really be more prepared for that. Here we go. So in video 2i, I started with f of x, and then from the graph of f of x, I found the graph of f prime of x. But now I want to go the other way. So here in video 2j, I started with a graph of f prime of x, and I showed how we could generate a graph of f of x using that. So you can go back and watch videos 2i and 2j and get a little bit more out of it. But I want to go to do this a little bit more carefully and a little bit longer. See going on. So the first thing I want to do is I want to find okay, so I want to find the area under the... Well, what I've done first off is I made I've made it 5 boxes by 5 boxes. So I'm going to say that the 12 boxes equals 1 unit. We can say that 1 box is 5 square units. So I can say that this area here I'm going to say that that's 1, 2, 5, 6. So 1, 2, 3, 4, 5, 6. But it's not 6, it's like 5 and a bit. So call it, I've decided to call it 5.75 boxes. If I divide that by 5, I'm going to say that that is 3 units. Okay, and then go here. Say that this is 1, 2, 3, 4, 6, 7, 8. Well, it's not quite. It's 1, 2, 4, 1, 2, 3, 4, 5, 6. There's 6 boxes, and it's almost 7 boxes, but it's not 7 boxes. Decided earlier that it's 7.2 boxes. One I decided on earlier, and that would be 0.28. And so then the two put together is 0.517 units. So I'm going to say that this has an area of and this is an area of 0.27 units. And so these two put has an area of 0.5 units. Okay, and there's another way that I'm going to do that is I'm going to back and do it a little bit of a different way. So has a value of 1, and this has a value of 1.3, and then this has a value of 1.57 and a value of 1.78. Find these points right here. So I'm going to try to go through, and this is the part where I'm going to go through things pretty slow. But I wrote it all down ahead of time. So I'm just sort of marking what the y value is for each. Call that 1.95. I'm going to call 2. I'm going to call that 1.2. I'm going to call that 1.8. Call this 0.5. 0.86. 5, 0, 5. So I'm going to go negative 0.4, 72, negative 0.92, negative 1, negative 0.9, negative 0.77. Oh, gotta move over. Sorry. 77. That's negative 0.5. Negative 0.25. 0.5. Call that one 0.3. Call this one 0.3. Call that one 0.5. And call that one 0.5. Okay. So now to do. Let me pull out a little bit further. Okay, so what I'm going to do is I'm going to say that this area there, I'm going to say that that is going, the average of 1.3 and 1 would be 1.3 plus 1 by 2. That's the average value of that. And so that's the average height, and the height. And then is going to be 0.2 or 1/5. I'll just call it that. And so that's my base. And so my area is going to be plus 1 divided by 2 is 0.223, just like I said 5 boxes is 0.23. Same answer, not surprisingly, because I'm essentially the same way. So I can either count the boxes, I can take the average height of the box, column, times the width of the box, and do basically base times height gives me the... Okay, so through this, you guys should really print out the so you should do it on your own, or you can also just sort of make up your own score. Here I'm going to go a little bit fast, because now what I'm going to do is I'm going to say that green is f of x. So, how much area do I have per row? Well, I don't have area. I don't have any area. Now, I determined a couple different ways. Of the first column is 0.23. So where to go, this is 0.2, so through right there. So I'm going to make a point right there. Now, I determined that the area of the second column is 0.287, and when I add 0.287 to this column, I end up with a total area of 0.57. So, when I add boxes when I have these boxes and these boxes, I go up 5 and 7. There's my 0.5, so 0.51 is above that. Okay, so now I'm gonna read off numbers, and this is where I sort of, what I did is I took these numbers that I generated, I put them into a spreadsheet. So, I mean, there's my, right there, right? You can pause on that if you, and basically what I was just doing is, here I've got 1.5 plus 1, 2 divided by 2 times 0.2, and that's going to give me an area. That's going to give me an area of 6.8 box, which is going to be 272 units. And so I'm just that sheet. And now I'm going to graph here. Add 8 plus boxes, and so now I get 0.8 is right there. There. And I go 9 plus boxes, and so I'm going to go to 1.2, and I'm right there. Next, go to 1.62, so there's 1.6, 1.62 is right there. Then I go to 0, so basically right there. 2.384, so I'm going to be there. 2.714, so right about there. 2.96, which is going to be almost 3. 3.194, which is going to be 1.2. 3.5, which is going to be up here someplace. 3.37, which is going to be just 3.325, so 3.37 is going to be up there. 3.33 is going to be right about there. 3.21 is going to be about there. 0.4 is going to be about there. 2 is going to be about there. 672. 2.5. And I'm going through this. I'm trying to balance tediousness to speed. So you guys can definitely sort of go through the at your pace. And then I got 2.373. So I guess I did that one already. Maybe I'm off by a little bit. That's 373 about there. That should be 3.5 online. A little bit off. This should be 3. So there's 3. 2.8. That should be so that one should be up there. .293 is right about there. Getting close to it. 2.273 is right about there. 0.38 is right about there. 0.381 is right there. 0.2 is right about there. 7 is right about there. And I miss. Okay, let's see what's going on. Okay. If I green curve, green curve, so this is f of x. The known green curve is the green curve is adding up the square units under the curve and how many square units I had. So here 2, 3, 9, 11, 12, 13, 14, 15, 16, 17, 18, 20, 22, 23, 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 13, 14, 16, 17, 20, 21, 22, 23, 24, 25, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 15, 16, 17, 19, 20, 23, 24, 25. That's each box 1 unit. 1, 2, 3, 4, 5, 6, 7, 8, 9. So a little bit less than 3.5. So here is a little and a half. So then if I go up here, I'm at a point which is a little bit less than 3.5. So the number divide 5 gives you the area under that, then I have there. I started with the area that is the area on the curve, but then I also want to show that f of x is the slope of capital F of x. So the derivative function is derivative of capital F of x. Okay, well so then let's look at this. So here, that said that the slope is 1. Let's do something a little bit darker. This is 1. Well, right there, my slope here, this says my f of x says that the slope of my line at this point should be about 2. So here it goes, you can see that it goes there over 1 box and up 2 boxes and up 2 boxes. So there's a slope of 2. Okay, now at 0, well, if you go up here, I see slope equals 0. Once again, here, slope equals 0. And, well, box somewhere in there. Slope 0. Equals -1. And then right up here, my slope equals -1. what I'm showing is that that the two things are equivalent. That x the two things that little gives the slope of capital F and the area under the f of little f of x to the value of the big function capital X. Okay, that's what I wanted to say in that video, and I'll let you think about that. And